we need to have a look of these MI250X GPUs from AMD. Okay, we are going to focus on the frontier system, the frontier compute node, because this is the typical node with MI250X. Here you have the high-level diagram of this frontier compute node. Okay, it has one AMD Generation 3 EPIC CPU, and on the CPU you can have 2 threads per core, and this is the CPU Generation 3 EPIC. Okay, and then you have 512 gigabytes memory, and you have 2 hard drives, and notably you have 4 MI250X GPUs. So 1, 2, 3, 4. You have 4 GPUs. And then you have infinity fabric between CPU and GPUs. Between the CPU and the GPUs, you have all these are the infinity fabric links. And also you have infinity fabric between the MI250s. This is the infinity fabric between the GPUs. And at the end, you have 4 slingshot interconnect, 200 gigabits per second Ethernet. So you have 1, 2, 3, 4 slingshot NICs. This is the node architecture of the frontier system. Okay, and we need to have a look at this MI250X GPU. This GPU MI250X has 2 graphic compute dies, 2 GCDs per module. So you have 2 GCDs per module. Okay, so the system, you have 4 GPUs. Each GPU, you have 2 graphic compute dies. Then you have 8 GCDs per node. Now, the 8 GCDs show as 8 separate GPUs to the operating system, SLRM and ROCm. So generally, it's easier to refer to the 8 GCDs as 8 GPUs. Okay, so we are going to call these 8 GCDs as 8 GPUs. Each node that has 8 GPUs with the following specification. We are going to just pass it. That's not our focus. Okay. The 8 GPUs are each associated with one of the 8 CPU L3 cache regions. All GPUs are connected to each other and to the CPU with AMD Infinity Fabric links. The 2 GCDs in the same MI250X have a higher bandwidth Infinity Fabric connection between them with 200 gigabytes per second. Okay, so we are going to have a look at these. What does that mean? 8 GPUs are each associated with one of the 8 CPU L3 cache regions. We are going to have a look at this one. Okay, so this is the logical architecture of the frontier node. You have this MI250X. You have 2 GPUs per physical GPU. And you have these 4 links. That's slingshot. Okay. And here you have this CPU. Now it's a big one. Oh, it has been drawn as so big. So this is a big CPU. Okay. It's just one CPU, but it has been drawn to show the details. So it's a big one. It's big CPU, and you have these 512 gigabytes of memory. What is saying that each GPU, you have 8 GPUs, each GPU is associated with one L3 region. Okay, basically, if you have just read my section 1, you know that we have the concept of NUMA domains or NUMA regions, or sometimes it's called the NUMA node, with this kind of AMD CPU. Normally, it has 4 NUMA nodes. Here you have 4 NUMA nodes. If you can do a partition of the I/O subsystem, I mean the I/O that if you can do the partition, you are going to have 4 NUMA nodes. Okay, and each NUMA node you have you have two L3 regions. What does it mean is that, you know, the AMD CPU is chip-like design. You have the cache, L3 cache here, and you have CCX. I think it was called CCX, compute complex. Okay, it's called CCX, and then you have this CCX. You have these 3, and each NUMA node, each NUMA domain, you have 2 chiplets, CCX and L3 cache and CCX. So basically, each L3 region is a chiplet. This is one chiplet. That means that for NUMA node 0, you have 2 chiplets. 2 chiplets, and each chiplet you have 8 cores. So you have 2 chiplets. This is the early AMD EPIC CPU. So it has 8 cores per chiplet, and it has 2 chiplets per NUMA node. And each chiplet is called a domain. And basically, in the previous section, basically this sentence is saying that the GPU, each GPU is connected to a L3 region like this. So this, the first L3 region is connected to GPU 4. The second L3 region is connected to GPU 5. This is what it means. Okay, so this is the logical architecture of the frontier node, the computer node. And then you have this infinity fabric between the CPU and the GPU, which is 36 plus 36 gigabytes per second. Here you have this one, and this one, and this one. And for each GPU is connected to one L3 region by one infinity fabric between the CPU and the GPU. And at the same time, you have infinity fabric between the GPUs. And this one is the link between the GPUs, is 50 plus 50 gigabytes per second infinity fabric link. Okay. And then you have these PCI links. Here is for the storage. You have this PCI link. Here is for the slingshot NIC. Okay, this is the logical architecture of the frontier node. Now, I've said that the CPU, it can be partitioned into 4 NUMA nodes. If you don't do that, the 4 NUMA nodes could be just one big NUMA node. You have one big NUMA node. Suppose for this example is that you don't do the partition, you have just one big NUMA node, and you have this memory, and this NUMA node is going to be connected to the 8 GPUs. Okay, you have 1, 2, 3, 4, another 4. You have 8 infinity fabric links to connect to the 8 GPUs. Or if you like, you can do the partition to have 4 NUMA nodes. If you have 4 NUMA nodes, basically from the Slurm point of view, you are going to have 4 nodes, and each node is going to be connected to 2 GPUs. These 2 GPUs are connected to the right NUMA node. Okay, so there are 2 ways to use the system. Either you don't partition the system, you have just one big NUMA node. Or you do the partition of the system, you can have 4 NUMA nodes. Okay, this is the from the user's point of view. Here comes the concept of the NUMA nodes. And then, very importantly, we need to go through this piece of information is that the CPU and the GPU accelerator components, the CPU and the GPU accelerator components share a flat physical memory space. Okay, any processor can directly address the HBM in any of the 4 accelerators, and all of the DDR4 connected to the CPU. Okay, and the cache coherency is maintained among all processors. Okay, a consequence of extending our cache coherent Infinity Fabric across the multiple packages is that it creates a single logical interconnection for both memory and I/O. This figure shows how each MI250X accelerator has a network interface directly attached, which allows network data to be injected directly into an accelerator's local HBM without routing through the host CPU. Okay, very importantly here is that the CPU and the GPU accelerator components share a flat physical memory space. Here, this memory space and the GPU memory. We have the GPU memory. The GPU memory and the CPU memory are unified. Okay, so this is kind of a unified memory, but it's discrete. It's discrete because here you have the CPU memory, and the other side you have the GPU memory attached to each GPU. So there you have GPU memory for GPU 0. Also, you have GPU memory. You have 8 GPU memories, each one attached to one GPU. So each GPU has its own memory. The CPU right now is saying the CPU and the GPU accelerator components share a flat physical memory space. That means this memory and this memory has been unified. It's kind of unified memory. So it's a physical memory space. Any processor can directly address the HBM in any of the 4 accelerators, and all of the DDR4 connected to the CPU. So that means whatever the processor, CPU, GPU, all the memory is accessible by this processor. Okay, so that's the meaning of the unified memory. Okay, so and the connection between the memory, the CPU, and the GPU, between everything, the connection is the Infinity Fabric, Okay, and the cache coherency is maintained among all processors. So this is a very important piece of information. Now, if you still remember, we have discussed the MI300A in the previous part. In the previous part, we have learned that the MI300A, it has a unified memory that could be accessed by the CPU and by the GPU on the same chip by going through the Infinity Fabric. And between this Infinity Fabric and this memory system, you even have another layer of cache. It's called the last layer cache. Basically, it's using the AMD Infinity Fabric cache. It's called the Infinity Cache. It's using the Infinity Cache. So in that system, all the memory are physically unified. Okay, all all the CPUs, all the GPUs share the same HBM memory that's on the APU chip. Okay, but here come to MI250. One point, there is one point, this is the key point, that makes MI250 is nearly the same. Logically is nearly the same as MI300A. Because what? Because MI250X it also has a unified memory. Even the memory is discrete. That means you have this 512 gigabyte memory, and you have the discrete GPU memory connected, attached to each GPU. So you have 8 of them. You have another memory attached to the GPU4. You have another one, you have another one. You have the 8 memory connected to each GPU. So you have all this memory discrete, means they are separated physically, but logically they are unified. They are a kind of unified, they are a kind of memory unified by using this infinity fabric link. Okay, so the compare this MI250X GPU, this frontier compute node with the MI300A, MI250X, this frontier node. If you compare it with the MI300A, there is one point that's common for the two. Here you have unified memory, which is physically unified. Okay, is physically unified. And here, what you have is also unified memory. Oh, it's not physically unified, but it's logically unified. So this is the common point for these two systems. This is the key point. This is the reason why I have classified MI250X the same as MI300A. Logically, we can believe the two systems are logically the same, even they are two different generations of products. But logically, they belong to the same category of products. That's this unified the system with the unified memory. Okay, so this part we have just talked about this MI250X, and the key message here is that MI250X, it has this kind of logically unified memory, and the logical architecture is the same as the MI300A, which use the physically unified memory. Okay, logically they belongs to the same category of products. Okay, this is for this part. Let's have a few minutes as a rest, and we are going to continue our discussion, and we are going to discuss the systems built by using the MI300A and by the super chip. Okay.